AP Calculus AB. Second fundamental theorem of calculus suggests to us that if we have big f of x is actually equal to the definite integral from c to x of f of t dt. Keep in mind this is this dummy variable, and it makes me happy to say that. This is a dummy variable. Another way this could be stated is that ddx of the definite integral from c to x of f of t dt is equal to f of x. Why is that true? Because here we have integration and differentiation. We have integration and differentiation canceling one another out. And what we need to get are a couple things. One, remember that f of x is the net area under f between c and g. And here x has to be in the upper limit. This is another really crucial point where's my point here I want to make to you, because it's really crucial to me that this x value has to exist in your interval a to b. Right? So it has to, this x value here has got to be in the interval somewhere for this to actually be true. So let me go over this example that I found for you, and the example is this one. And it's find the derivative. Find the derivative here. F of x is equal to the definite integral from pi halves to x of cosine t dt. Whoops, dt. So we want f prime at x, right? Find the derivative. And remember that f prime is equal to f of x here, isn't it? Which is equal to df du times du dx. This looks terrible, but this is just the chain rule. This is the outer function here, and this is the inner function. Right? And when we use the chain rule, isn't that what we do? We take f prime at g of x times g prime at x, and that's what's happening right there. So that shouldn't freak us out too much, I don't think. So I'm just going to keep writing and say that, well, that's the same as ddu of x cubed over, I'm sorry, not over, but from pi halves to x cubed of cosine t dt times du dx. This is, stay with me because this is going to make sense in a minute here, I think. And this is one thing that I'm going to do. So right here, I'm getting a little bit confused. So what I'm going to do here is I'm going to do this. I'm going to make this last thing. I'm going to say let u equal x cubed. If that's true, then du dx, right? Then du dx would equal 3x squared, right? And here I am picking up these pieces. Okay? Du dx. So what I'm going to do from here, having gathered this piece of information, I'm just going to rewrite a little bit. And I'm going to take this, and all I'm going to do here is I'm going to substitute this also and say du of the definite integral from pi halves to u of cosine t dt du dx. All right, now I think we're finally starting to get where we're going. Let me have just 1 second to take a quick look here. Okay, so that takes us to this, takes us here to just cosine u, right? This cancels this, right? Differentiation and integration canceling one another out. So cosine u times 3x squared. Well, that makes sense, doesn't it? That's this piece right here, right? This canceling this. We're substituting u. I should have put u here, I think, shouldn't I? I kept it t. I could change it to u now, right? And then, so here's my answer. So I'm hoping this is helpful. I'm going to do a ton more problems, ones that are more difficult, and we'll talk about that often. So hopefully this video makes some sense to you. What I would do is start practicing these problems, and as you're practicing the problems in your textbook, go back to this video and see, okay, what was kind of the next step. All right?